This video will cover a solution guide to problem 52 from chapter 1. A maser is a laser-type device that produces electromagnetic waves with frequency in the microwave and radio wave bands of the electromagnetic spectrum. You can use the radio waves generated by a hydrogen maser as a standard frequency. The frequency of these waves is 1,420,405,751.786 Hz. A clock controlled by a hydrogen maser is off by only 1 second in 100,000 years. For the following questions, use only 3 significant figures. What is the time for one cycle of the radio waves? How many cycles occur in 1 hour? How many cycles would have occurred during the age of the Earth, which is estimated to be 4.6 times 10 to the 9 years? And by how many seconds would a hydrogen maser clock be off after a time interval equal to the age of the Earth? So first let's find the time it takes for one cycle of the radio waves. The problem gives us the frequency. Because it only wants 3 significant figures, we can simplify that huge mess of numbers it gave us in the statement to 1.42 times 10 to the 9 Hz. Another way of writing the unit Hertz is as cycles per second. This makes what we have to do a bit more clear. Part A asks for the time for one cycle, so all we need to do is take the reciprocal of the frequency in order to get the period. Doing so gives that the period of the radio waves is 7.04 times 10 to the minus 10 seconds per cycle. Part B is simply asking us to transform the frequency from being reported in cycles per second into cycles per hour, so what we need to do is multiply by conversion factors until we get the units we want. The cycles part is fine, but we need to turn seconds into hours. To do this, we can use the fact that we know that there are 60 seconds per minute and 60 minutes per hour to turn that unit of seconds into hours. As you can see, the way we have this conversion set up is correct because all the units that we don't want in our final answer will cancel out, leaving us with a frequency equaling 5.11 times 10 to the 12 cycles per hour. To find how many cycles will occur during the age of the Earth, we need to convert our answer from the previous part into cycles per year. To do this, we use the conversion factors between hours and days and years. Checking to make sure our intermediate units cancel, we see that we are left with a unit of cycles per year. We can then multiply this by the age of the Earth. This will make the years unit cancel, and we are left with 2.1 times 10 to the 26 cycles occurring during the age of the Earth. Now we're switching gears a little bit. The problem statement told us that every 100,000 years, the maser is off by 1 second. If the Earth is 4.6 times 10 to the 9 years old, we can multiply its age by the 1 second per 100,000 years to figure out how many seconds the maser would be off if it had been allowed to run this long. It turns out it would be off by 4.9 times 10 to the 4 seconds, or roughly 14 hours.